everyone. Thanks for coming, especially 9 a.m. after a concert. How many of you made it out last night to the Chainsmokers? Oh, wow, a lot of you, and you're here, so well done to you. My name is Stephen Butschi. I lead our higher education team at Google, and this session is on disaster recovery and storage. And we've got some great universities here that will be speaking, but I'm sure you probably all remember the news from about a year ago dealt with Hurricane Harvey, and that we happen to have a school district that reached out to us and said, we learned a hard lesson. Your disaster recovery site should not be located just 30 minutes from your main data center because that may also be affected. And they reached out and said, we're having some problems. If you could really help us out. And the good news is with Google Cloud Platform and G Suite, we were able to step in and help them recover from this. But I think what we want to talk about as we hopefully today is helping you avoid what happened with Hurricane Harvey and making sure that you're thinking through your strategy. So as you hear from these three universities, you'll hear a little bit of the first two buckets. So I wanted to call this out because there are different types of storage. The first being G Suite. This we offer for free to many institutions that are educational. In fact, all of them, they're not for profit. And so that is really around file storage as you think about backup and recovery. So things like essays and manuals and presentations, collaborative docs. So you'll hear from Steve from University of Minnesota about how they are using Google Drive for backup and storage of those types of materials. The second bucket is around Google Cloud Platform and our storage classes. So that is more object storage. So think about disaster recovery, large sets of genomics data, etc. We also have other types of storage, such as block storage and structured data through Cloud SQL. And I put the link there because there are so many to list that I won't be able to go through them all. But if you want to check that out on the website, there's more details there. So when we think particularly around disaster recovery and storage for Google, I think there's four key terms that we are trying to design for. Trust, secure, smart, and simple. So if we go into that, for example, with Google Cloud Platform, one of the things you have to do in order to trust someone is make sure that if you're going to put all of your files or your object storage into Google, is you trust this will actually be available when you need it. And so this is some data from Gartner looking at the downtime of storage from the different cloud providers, and hopefully we're recognizing that we will be there when you need us. In addition, there are a few other features that I think differentiate when we're looking at cloud storage options. One is a single consistent API, so you don't have to manage multiple APIs, and that API actually works with other cloud providers as well, which makes it really easy to move data. Edge caching, given our network, making sure that the data can be easily brought to you quickly. Consistency and things around security like default encryption, that's automatically encrypt data at rest and in transit, as well as object lifecycle management. So as you look at, for example, our different buckets of storage, going from hot and multi-regional all the way on the left to cold, which is really just archive, we can really easily help you move your storage through that process automatically through lifecycle management. The benefit of that to you is that if you're not touching something, you can move it down in a class and it'll save you some money. So as we go through this process, and I'm not going to read through all these different buckets, but just remember that we have many different scenarios and different options to match what you need for disaster recovery. So as we go from there, I'm going to introduce three of our speakers. We'll have Arun from Stanford, who will be talking about how they're using Google Cloud Platform for their disaster recovery. Steve from University of Minnesota, who will be talking about how they're using G Suite for a lot of their file backup. And Joshua from Georgia State, also talking about how they're using Google Cloud Platform. And then at the end, we'll take questions. So if you have any questions, feel free to jot them down. We have a microphone, and I will be moderating that discussion. So from there, I'm going to bring up Arun to tell us about what they're doing at Stanford. There you are.
Lead cloud engineer at the Stanford Graduate School of Business. Let's dig right in. Let's talk about disaster recovery. As an introduction, I'd like you to look at this picture. It's a beautiful picture of San Francisco, the cityscape in the background, the fog rolling in, and the very famous Golden Gate Bridge peeking out.
I'm going to give you this. There you go.
Is that on? Okay. And the very famous Golden Gate Bridge peeking out. San Francisco is truly a beautiful city, and I hope in the last few days you've been able to take a few minutes to look around, enjoy the sights and scenes. But San Francisco is known for one other thing, and that's earthquakes. We who live here know about these natural disasters very well. This entire area is situated on 6 major fault lines and a slew of smaller ones. In fact, geologists predict that in the next 25 years, there's at least a 70% chance of a significant quake hitting on one of these faults. Could happen tomorrow, could happen next year. You don't know. But what we do know is the damage that earthquakes can do. Back in 1989, we had a 6.9 earthquake that hit San Francisco, the whole area. It was dubbed the World Series earthquake because it happened just moments before Game 3 of the World Series in 1989. That was between the San Francisco Giants and the Oakland A's. The San Francisco Giants and the Oakland A's just across the bay. And you can see what damage it did. A big gaping hole in the Bay Bridge, a downed building in one San Francisco neighborhood. Both of these were just moments away from where we're sitting right now. So let's bring this back around. If you, as an IT professional, are responsible for your critical data for your organization, and you happen to live in an earthquake-prone area, or any place that has disasters, you want to make sure that that data is safe. This morning, I'd like to take you through our journey of creating a disaster recovery plan. In doing so, I'll talk about 3 major topics: why we chose the cloud, why we chose Google, and how we achieved disaster recovery with 0 downtime. The Graduate School of Business at Stanford has over 200 terabytes of critical research data. This data is sitting on our NAS, on-premise, on storage disk from a major storage vendor. Our faculty researchers use this data to create and publish major papers on topics from anywhere from international economics to human behavior. This research is world-renowned, and it's critical to attracting top talent to the university, both faculty and students. Amazingly, as of just 2 years ago, this data was not even backed up. Clearly, we needed a disaster recovery plan, and we needed one implemented very quickly. As we talked about it, many requirements came to mind. We wanted to make sure that our disaster recovery plan was geodiverse. As I've just been talking about, we didn't want an earthquake to hit a data center and take out our NAS and our DR solution all at once. Our solution had to be highly available. Our solution had to be scalable. As our data footprint grew, we wanted the solution to grow with it without any major re-architecture. And we needed quick recovery times in the event of a disaster. As we did our basic research, it was clear, and we were pointed very quickly to using the cloud. It was the most efficient, the most cost-effective way of achieving these various goals. Add to that the fact that the university had recently printed its Cloud Vision statement. In it, it stated that the university wanted to move the majority of its IT infrastructure out to the cloud by 2019. That's just next year. But that confirmed the direction that we were going. I'll let you read Stanford's Cloud Vision statement, which is up here on the screen, and it will again point out the key words: cost efficiency, scalability, and accessibility. Cost, of course, is a big factor on any major initiative, especially when you're dealing with university budgets. In our case, when we started thinking about disaster recovery, we thought, hey, why not just bring in another NAS, bring it on premise, copy all the bits from our production NAS to the second NAS, and thereby we would have our solution. We talked to our storage vendor, and they sent us a quote. The quote came in at $137,000. Not chump change for us. Further, that didn't include the installation costs, nor did it include the system administration costs that we would need to bear over the lifetime of this new solution. Google Cloud Storage, by comparison, had minimal upfront costs, and it billed monthly, depending, of course, on the size of your data footprint. We estimated that in the first year, that would come out to around $60,000 for us. You can see the big price difference. Beyond cost, there were many other reasons as to why we chose Google. Our university had already a pre-existing business agreement with Google, and in that agreement, we could store high-risk data out into GCS and even PHI data. That was important to us. Second, we had a fantastic team assigned to us from Google. Once they learned about our project, they worked hard to find the right solution for our DR. They communicated with us continuously, and as a matter of fact, we met at this very same conference a year ago. I was able to sit down with them, talk about our needs, talk about our requirements. They took lots of notes, they went back, they figured out some possible solutions, and they came back quickly. Once we talked about it, we discovered that there was a particular Google partner that would potentially serve our purpose very well. I'd like to go into a little bit of detail about that particular partner. That was a company called Comprise. Comprise is a company and a software that allows you to analyze, move, and manage your data across all your disk volumes and, in fact, across object stores out in the cloud. Together with GCS, the Comprise software provided for us a complete DR solution, and one that we have in place today. The company itself was wonderful to work with. They developed a collaborative relationship with us. They were eager to hear our feedback. We were eager to give them our feedback. And in fact, much of that was introduced into future versions of their software. That's all fine and good, but what really sold us on Comprise was the capabilities of their software. From this picture, I hope you can see that we were able to replicate all 200 terabytes of our research data out to GCS. Moreover, and this is important, the files came over while preserving all file attributes. More specifically, it preserved all security file attributes. And even more specifically, it preserved NFS v4 security file attributes. We came to learn that NFS v4 is not highly supported, but it was critical to our solution. Once all of our data was out at GCS, the Comprise software then allowed us to actually mount that Google GCS bucket back to our on-prem compute hardware. I hope you can see then that if our NAS ever went out, we could simply mount the GCS bucket and we would be up and running with our data with zero downtime. As they say, that's exactly what the doctor ordered. In conclusion then, I want to state again how important it was for us to achieve disaster recovery. We did it with GCS and with Comprise, and together they formed a solid solution that, again, is in place for us today. Looking ahead, now that all of our data is safely out into the cloud, we could imagine, hey, maybe instead of having our on-premise data, maybe our primary store should be out in the cloud. And if we did that, we could then take the next step and think about, hey, maybe we should put our compute out in the cloud. In essence, we would have Google do all of the infrastructure heavy lifting for us, and we could concentrate on what value add we're there for, namely the data analysis, data integration, and that sort of thing. Putting all of that compute out into the cloud also minimizes our on-prem footprint, which is a very good thing. No servers, no administration, no headaches. And when you live here in an earthquake-prone country, as I was talking about, you don't want to mess around with losing your data and your compute. Thanks very much. I'm going to hand it over to Stephen.
Thank you, Arun. Hi, everyone. My name is Steve Nguyen, and I'm with the University of Minnesota. I'm the service owner for collaboration and web content services. The University of Minnesota is comprised of 5 main campuses across the state of Minnesota. The Twin Cities being the largest, we have about 100,000 students and approximately 35,000 faculty and staff. My role here is to ensure that the service is delivered through operations, process improvement, and through strategic direction in the collaboration and web content space. What I want to talk about next is the University of Minnesota and how we have 200 million files and 2.3 petabytes in the cloud. We're ready for storms, tornadoes, and even the occasional squirrel. And I'll explain that one later. While we don't have earthquakes like Arun did, we have other things that cause us to think about DR. And so I want to walk you through how we've done it here at the university and how you can do the same. The university has been an early adopter of Google since 2009, but we didn't all jump right in. As I look back to those days in the late 2000s, we were contemplating about moving to Google as a collaboration platform. We had pockets of users using Google and wanting leadership and others to move into this direction, but the rest of the campus didn't have an appetite for it. Faculty were concerned about storage, how they access their files, where they find it. Administration were concerned about security, performance, and uptime. But all in all, the questions really boil down to 2 things. 1, can we trust Google? And 2, will Google be reliable? So through a series of town halls with stakeholders and with leadership, we concluded that the benefits of the cloud just far outweighed those concerns. For example, we used to use Word docs. You know how you create them, you send them off, someone would download them, make changes, send them right back. Since we moved to Google Docs, the experience for our users has been just tremendous. They now have an anytime, anywhere, and any device real-time collaboration. We also wanted to strive after a high availability infrastructure. So we asked ourselves, as an institution, how do we minimize the downtime that students, staff, and faculty have in using these products? And so we were after high availability to the 5 nines. And I think we pretty much achieved that with Google. But the largest benefit, however, is in the savings. And that's what I want to talk about next. The savings we achieved from going to Google were in time and money. We used to spend a lot of time managing servers, patching them, monitoring them, troubleshooting them. You know how that works. And usually we get a vendor patch, and we apply them, and we think that they've tested it thoroughly. They didn't. We applied them. Of course, disruption and disaster, right? Well, since moving our files to Google, we don't have to worry about that anymore. Google does a better job of it than we can, so why not let them manage it? So our sysadmins now really are focusing on other priorities where their expertise is needed in that area. The other benefit that we mentioned were the savings in terms of money. We asked Gartner to come in and do an independent analysis of what the savings would be if the university moved to an all-cloud platform, collaboration platform, versus building something on-prem. They determined that the university would save approximately $15 million. For those in higher education, that's not a small number, and it's always a decreasing budget every year, right? So we're asked to do more with less. And so my question to you is, what could you do with $15 million in that savings? Well, what we did was we went to administration, went to faculty, and we said to them, here's something you don't hear every day. Here's $15 million for you. What do you want to do with it? They came back and they said, we want this, a collaborative teaching and learning classroom. This is where the university invested the savings. This building here houses 10 of the high-tech active learning classrooms that we have on campus. For those who aren't familiar with what high active learning classrooms are, They are classrooms designed to offer a flexible environment that encourages group work, class participation, and increased participation. Students here are working on projects together. They're collaborating, sharing the results within each other in the classroom through technologies implemented in that building. This facility is also a big draw on campus, not only for teaching and learning, but for also other events that need a collaborative learning space. Stephen can recall that he was here at this same place in March for our Google Day event, using the facilities and the equipment in this room. But these students, however, have an ever-increasing expectation of availability and reliability on the enterprise applications that we have in our data center. And so I want to take a look at two examples of where the impact of those data centers caused a DR situation. The picture on your left shows you a large body of Minnesota water, and the picture on your right shows you one of the university's data center. Imagine all this water flooding into that data center. When that happened, obviously our files and servers were unavailable, and our users were very upset, and they didn't want this to happen again. And so we thought about how we would mitigate this, and so we said we needed to have a cloud file storage solution that would allow the users to continue to access their files and store them without having to worry about a flood, because moving the data center was not an option. And so what we wanted to do was we looked and moved the files that we had to Google Drive. And so our most recent flood wasn't as severe as the first one, but when it happened, we were already in the cloud, and we were unaffected by that from a user standpoint. My next DR example occurred when we had an important upgrade that we went live with. We had a complex year-long project to upgrade a key business application, and the upgrade was complete, and we were ready for the launch. On the day of the launch, one of the transformers powering our data center blew up and caught fire. And obviously, this delayed our launch. Anybody care to guess what caused that transformer to catch fire? Yeah, good, you guys are paying attention. That's right, so hard to believe, but a squirrel somehow found its way into the transformer, built its nest or whatever, and caused the fire to take down our data center. Yeah, this caused IT to have a huge black eye. So all credibility and trust with IT went out the window that day. It took us a long time to rebuild that relationship and earn their trust again in our partnership with them. You can plan for anything you can't really plan for anything that's unexpected, right? And here are two examples of that. I can share more of just some of these crazy stories that you just can't plan for. But by leveraging Google, what we did was we took all of our files that everybody was using and put them in the cloud to prepare and plan for these uneventful or unplanned events that happened. Like our users, this squirrel here was just looking for a safe place to store its nuts, right? So isn't that what we're here to learn about how we can securely store our files? Now that we talked a little about DR, I want to switch gears and just talk about team drives. Imagine a scenario with me for a second. You have a staff person who's been with your place for 7 years, creating content and so on. They're ready to move on now, and now it's time for them to go. How does an organization effectively offboard that person while retaining these documents and make sure that they don't leave with that person? How does your organization do that right now? Well, prior to team drives, whenever a staff person left, they had this daunting task ahead of them, which they didn't want to do, and that is that their teams needed them to change ownership of all the working documents that they had and assign that to a new person. And this was a process that was very haphazard. It was painful for the business. Staff person who was departing really didn't want to do this. I've got another week left. I'm not going to sit here and spend hours trying to change ownership of documents. And so we usually have to contact that person after when they left and ask them to reassign these documents to another person. Well, Team Drives improves this for us, and it allows the team to own the documents versus an individual. And so Team Drives helps us have a better offboarding experience and allows us to improve that process in a more effective way so that the documents stay with the organization. So in conclusion, you can see how we've done at the university, focused on security, performance, availability, real-time collaboration, and with team environments. The savings we gained from moving to Google allowed us to reinvest those funds into areas where the student learning experience has made the university one of the top places to attend. And going forward, we want to be able to look at moving to an all-cloud file storage solution where applicable, and continue the momentum of moving these files that we have to the cloud. We want to continue to develop team drives in an environment for colleges and business units to put their files in and have a better offboarding experience. As you can see, we have 200 million files, and we're just getting started. Thank you. And I'll hand it over to Josh.
Good morning, everyone. My name is Josh Humphrey from Georgia State University in Atlanta, Georgia. And this morning I'm going to share with you how Georgia State has moved into the cloud and how that move has greatly improved our overall disaster recovery planning. Our main priority was how could we better protect the university's data without breaking the bank in the process. So many of you may remember a small storm that happened last year. Hurricane Irma and the destruction that it caused. Atlanta, which normally does not receive storms of this caliber, was in the projected path as it was entering the U.S. So since this was our first major storm that we were going to face, luckily we had already started moving our backup data into Google Nearline storage. We knew this storm was going to put GCP to the test, and we felt very confident that we were going to be able to access our data in case the worst were to happen. So knowing this information, we were able to not worry about how secure and how safe our files were. The whole team could then focus on more pressing issues as we prepared for the storm to hit. Luckily, at the last moment, the storm weakened and actually changed course, so we did not have any major outages, but it did help us prepare for any future ones that may come down the road. So our initial move to the cloud was very small. We took very small baby steps. We had an initiative several years back that was wanting us to move some of our workloads into the cloud. So we decided to not focus on major applications and systems. Instead, we decided to keep it simple, and we targeted our 100 plus terabytes of our backup data. The reason we targeted this was we were the ownership of the backup data, so we didn't have to deal with other application teams, and we didn't have to open up a lot of extra security rules and stuff. Working with those teams, we could do it all in-house. So knowing that our backup application actually supported multiple connections to clouds, we chose Google Nearline, and we decided to start a pilot. So within a couple of days of deciding we were going to do this pilot, we created our GCP accounts. We then created our storage buckets within Nearline, and we connected our backup application into the storage buckets. The next step was we created a new storage policy, and we dumped a couple of our dev systems into that storage policy to have that data start shipping off to Nearline. So for about 2 months, we let that system run while we learned, how to manage this data, what was the process of adding new systems, what was the process of restoring, so on and so forth. So two of the main questions that we were asking ourselves while we were doing this 2-month pilot was cloud going to work for us for our disaster recovery planning for our backup data? And was Google going to be the best option for hosting this? So after the 2 months time frame, we found out how easy it was to add more systems into Nearline, found out how easy it was to restore these systems, both at a file level and a full server level. And so at about 8 months, we were good. We decided to go all in and pushed all of our backup data into Google Nearline. So now that we were all in, it was time to toss our security blanket aside. And doing this saved us a lot of time and money. And let me explain. So prior to getting rid of our security blanket, we were using tapes as our DR plan. So every day, tapes, our backup data would be copied to tapes. We had a dedicated team at our data center who would go in, rotate the tapes. We had a third-party company come in, pick up the tapes, send them off to a secure remote site. If we ever needed to restore anything, we would contact that company, hoping that we requested the correct tapes. They would bring them back in, we'd load them into our tape library, and all that to just start doing a restore. So we decided it was now time. We felt confident in Google and the ability to restore this data in case we needed it. So we decommissioned that tape library and became 100% dependent on GCP in case of disaster or any other type of emergency. So now that we no longer had the tape library, we no longer had the other hardware costs associated and the other third-party support, we saw an average savings, yearly savings of around 44%. And we've been using GCP for almost 3 years now, and we've seen this about the same time, amount every year. So as Steve said, in education, that is a huge amount when you're dealing with budgets that aren't constant year to year. And because this is such a significant number, we often use this whenever people ask us, why did you move to the cloud? And we just bring this up and say, this is our savings. So this is one of the big reasons we moved, usability and the savings. Aside from the cost savings, we also were able to reallocate about 10 of our data center workers into other areas of the IT department where their skill sets could be better used. So instead of working on swapping out the tapes and everything, those individuals could then go work in either our help desk, someone went into our server admin team, and someone went into our networking admin team. So it was better use of their time, better use of the university's time and money, having them moved out and into the other areas of the university. So now that we were all in with GCP, with using Nearline, we were now able to reap some of the benefits of using cloud services, three of those being location, access, and growth. So being in Georgia, we have a 30-mile requirement for a DR site. Google's data centers are far beyond Georgia's boundaries, so we immediately gain that ability of, or that check mark of, is your data outside of a certain mileage radius in case there was a disaster recovery. We also have the ability to simple configuration change, and we can then have that data replicated to one of many other data centers within the country. We also have near instant access to our data. Like I mentioned before with tapes, we had to contact the content or the tape library company, have them ship the tapes back to us before we could even start that restore. Now, through our backup application, a couple of clicks, and we started streaming our backups back to our data center almost near instantly. And we also have the ability to grow and expand our retention rates for our backups without the cost of extra hardware, without the cost of the extra cooling in our data centers, and the electricity that comes with that. So now within our backup application, one configuration change, and we've expanded our overall retention rate. We can add days, weeks, months, even make it indefinite, and it only costs us the monthly storage bill from Google. So since we're utilizing Nearline, we recognize that we're still only scratching the surface of the services that Google and using cloud technologies provides us. So one of the main things that we're looking for in the future is how can we get to the point where we can utilize a lot more of the services that Google provides, and hopefully with the ability to one day just flip the switch and have all of our mission critical systems come online, near instantly within GCP, so we can continue running our data center as seamlessly as possible, and then see what other integrations we might be able to utilize from that Google offers. So in conclusion, my advice to any of you all in the audience who is looking to either start your journey into using cloud technologies, or if you want to expand on your current environment, is very much to just keep it simple and start with the small things. Since we had an initiative and we decided to not focus on large applications, we just took small chunks of things that we knew we could get those easy wins with. That's kind of the biggest advice I could give to anybody is, we all probably have a big picture of what we would like to get to in the long run, but find those little pieces of that picture, try to get successful in those, and then as you work on those little pieces, the success rate keeps going up and up, and then eventually you've covered the whole picture that you were looking to do. And thank you.